Hi everyone, my name is Muntasir Syed, and we have a team of 4 people here, or we're called Team Zero. And what we built is called a leak detector system for industrial IoT. So let's proceed to the slide. All right. So the problem that we're looking to solve is basically leaks in industrial level piping. So manufacturing facilities, industrial facilities have miles and miles and miles of pipes, and if there's a leak in one of those pipes, it causes a lot of, there's a cascading failure effect, causes a lot of processes to shut down, slow down, and things like hazardous substances, they require a lot of downtime, a lot of maintenance, and it could be potentially hazardous for people working in these environments. And we must have a scalable solution that kind of addresses this issue. So we built a system that has a 2-tier detector for leaks. The first tier involves using gas sensors. We use the MQ series of gas sensors, which are very cheap. The entire system can be built for less than $30. And we ran an analysis of all the data that we are posting to Google Cloud. So basically we have a set of gas sensors, temperature, humidity, and we post all of these guys to Google Cloud, and then we analyze the input data for any anomalies. So once we detect an anomaly, we have our secondary system that uses IR imaging to look at the target locations. And so here's some of the technology that we used. Okay, so these are IR images, infrared images of regular pipes. So as you can see, they're very uniform. So what we did is we collected a bunch of pictures, IR images of regular pipes and IR images of leaked pipes, and we built a machine learning classifier that could take an IR image and figure out whether there was a leak in this pipe or not. So what we ended up doing is we deployed this machine learning model on the cloud. In a production system, this would be done on Google AutoML. I built out the system using TensorFlow, which is basically what AutoML runs on. So here are sample IR images of pipes with leaks. You can see that the IR signature of a leaky pipe is markedly different than that of a regular pipe. And our system is able to detect that. Once we have detected and localized leak somewhere in the system, the user or the operator gets a message using his cell phone and also on his dashboard that says there's a leak, a potential leak at this location, and the IR images are uploaded to Google Storage, which the user can then access. So here's a system diagram that Mila is going to talk about.
Hi there. I'm going to show you a Google product that we use, and let's use our imagination. We're starting from the top left corner. Imagine we have a facility or factory that has old pipes, and along the wall we have a sensors that send MQTT data to a Google Cloud, which goes to IoT Core, to the PubSub, to the Cloud Function. Cloud Function will decide if there is a possibility of leaking or not, and will send data first of all to the monitor on the top bottom corner, and will send a notification to the operator or manager. And also, the most important part, it will send a command through the IoT Core to the infrared camera that will take a picture and send it back to the cloud. That will be sent to the AutoML, and machine learning will process that images and will define if there is a leak or not. So once we have the data, operator will get a notification again with the notification if there is a leak or not.
So let's look at a video that we did of our system working end-to-end.